Hello and welcome to my Atoms and Electrons past paper question set. So this question is about ionization energies, and it's on the ionization energies of specifically rubidium and strontium. So we need to write an equation to represent the second ionization energy of strontium. We need to include the state symbols. And why is the first ionization energy of strontium larger than the first ionization energy of rubidium? And you need to spell all your technical terms correctly. And why is the second ionization energy of rubidium larger than the second ionization energy of strontium? Another 2 marks. And this question is on the structure of an atom. You need to complete the table about relative charges of relative masses and position within the atom of a proton, neutron, and an electron. And we need to define the term first ionization energy. So that's 3 marks. And we need to find out the number of electrons in the 2p orbital, the 3s subshell, and the 4th electron shell. That's a full shell and not subshells. So give you about 20 minutes to do those sets of questions, and pause the video and come back when you think you've completed it, and we'll go through the answers. Okay, so the equation for the second ionization energy of strontium, I'll just change that from oxygen to SR. But other than that, you do need to represent the first ion as Sr+, which is in a gaseous state, and then strontium 2+, which is also in a gaseous state. That's 2 your 3 marks, and to get the third mark you need to have an E- there. There are no states symbols for an electron. And why is the first ionization energy of strontium larger than the first ionization energy of rubidium? The answer is, as you go down the group, nuclear charge and atomic radii increase. The electron shielding increases, and so distance from the nucleus and increased shielding overcome the greater nuclear charge. 2 marks for that explanation, and 1 mark for spelling electron shielding and nuclear charge correct, I believe. And for part 3, electrons in ions are more attracted to the nucleus, and electron shielding also decreases. So, filling in the table, we have +1 relative charge, 0 charge for a neutron, and -1 charge for an electron. Relative masses, just +1, 1 and 1/2000, and position for both of the proton and neutron is in the nucleus, and that just putting them in that table gives you 1 mark. And the 2p orbital contains 2 electrons, the 3s subshell contains 2 electrons, and the 4th shell contains 32, as the electron configuration goes 2, 8, 18, and 32. And if we go on to the next 2 questions, iodine has a stable isotope with a relative isotopic mass of 127. And the relative isotopic mass of 131, which is the radioactive isotope of iodine. And we need to find the different values for protons and neutrons for iodine 127 and 131. And we need to draw a dot across diagram to show bonding in calcium chloride. And for this question, we get given the ionization energies of fluorine, neon, and sodium. We need to explain why there is an increase in the first ionization energy between fluorine and neon, and we need to explain why there is a decrease in the first ionization energy between neon and sodium. So this particular question is worth 3 marks as well. It's not listed there on my screen. So 13 marks for 13 marks. There's 12 marks for this particular two set of questions. That must just be from a different paper with 12 marks in it. So we'll give you about a quarter of an hour in order to do the questions. Come back when you have done them. Okay, so relative isotopic mass, real quick definition, is the weighted mean mass of an isotope when compared to 1/12 of the mass of an atom of carbon-12. So the number of protons in iodine is 53, and 53 for iodine 131 as well. So if we do a quick calculation, 127 minus 53, we get 74 protons, and 131 minus 53 is 78. So 74 and 78 are our two values there. And the calcium chloride diagram, if you just draw brackets around the calcium and make sure it's a 2+ ion, and the chlorine, let's put the dots there, and we have a minus charge there for one chlorine atom. Yes, this is meant to be a dot. 7 electrons on the outer shell, 1 coming from the calcium. So if we put a massive 2 there, that just represents the 2 chlorine atoms bonding to 2. Well, we're using the 2 electrons from the calcium in order to bond to it. So the next part of this question now. From fluorine to neon, nuclear charge increases similar electron shielding. There is similar electron shielding, as outer electrons are in the same shell. Greater nuclear attraction are on the outermost electrons as you go down the group. And sodium has more electron shells, therefore greater shielding. Less nuclear attraction on the electrons and shielding, the distance between the nucleus overcomes the greater nuclear charge. So that's 6 marks for question 16. For question 14 and 15, you just need to remember the charges on the ions and using the big 2 to represent 2 atoms, so you don't have to draw that out again. And the fact the protons and electrons are exactly the same, and neutrons here are different depending on isotopes. Just use the mass number and take away the proton number to find the number of neutrons. And for question 17, now we look at sulfur, and we need to find the relative atomic mass of the sample of sulfur. We need to define relative atomic mass, and we need to write in the proton and electron and neutron numbers for 33 sulfur and 34 sulfur 2 minus. And there's a sketch graph to show the trends between ionization energy across period 3 and atomic radii across period 3 as well. So give you, it's just 2 marks, give you about 10 minutes in order to answer the questions, so come back when you have done the questions. Okay, so relative atomic mass is the weighted mean mass of an isotope when compared to 1/12 of the mass of an atom of carbon-12. And the relative atomic mass of the sample of sulfur is 32 times 95.02 over 100 plus 0.76 over 100 times 33 plus 4.22 over 100 times 34, and this combined gives us a grand total of 32.09. And for the table, 16 protons, 16 electrons. 17 and 18. And for the sketch graphs, you just need to draw a line. It is not completely obvious in the question, just needed to do this and you would have got 2 marks. And for this one we need to complete an electron configuration for a magnesium atom, and the second ionization of energy of magnesium is that. We need to write an equation to represent the second ionization energy of magnesium. We need to include state symbols. And we need to explain why magnesium has a greater second ionization energy than strontium. So we'll give you about 7 minutes in order to answer the questions, and off we go. Okay, so the electron configuration is 1s2, 2s2, 2p, 6, 3s2. Now the 6 is meant to be a superscript, so I'll just rewrite that again. And for the equation, Mg plus gaseous goes to Mg 2 plus gaseous plus E minus, and the atomic radii in electrons shielding increases as you go down the group, shielding in the distance from the nucleus overcome the greater nuclear charge. And for the third mark, spelling the words electrons shielding and atomic radii would have got you the marks. So that's it for this video on past paper questions. I hope you found this useful. Leave me a comment if you didn't like it. If you want to try the questions again, I've left a link in the description with a PDF of all the questions. Thank you and goodbye.